Alright, so now we're in chapter 8.5, which is systems of inequalities. Here are our objectives. And we first start off by talking about the definition of an inequality. Unlike an equation that has an equal sign, inequalities use greater than, less than, greater than or equal to, or less than or equal to. And that's what makes them inequalities. A solution to an inequality in two variables is one where you input or substitute the x-coordinate for x and the y-coordinate for y, and you will obtain a true statement. Each ordered pair solution is said to satisfy the inequality. The graph of an inequality in two variables is a set of all points whose coordinates satisfy the inequality. So then we talk about the steps for graphing a linear inequality. First thing you want to do is replace the inequality symbol with an equal sign and graph the corresponding linear equation. Draw a solid line if the original inequality contains a less than or equal to, or a greater than or equal to symbol. Because you have equality, you draw a solid line. Draw a dashed line if the original inequality contains a less than or greater than symbol. No equality means dashed line. Step 2. Choose a test point from one half of the plane. I always seem to pick the point 0, 0 if it is available to me. Substitute this test point into the inequality and see if you get a true statement. If you get a true statement, shade the half plane containing this test point. If it is a false statement, shade the half plane not containing the test point. Alright, examples. Let's look at number 1 on page 847. And it says, graph each inequality. And we have the inequality x plus 2y is less than or equal to 8. So the first thing we need to do is replace that inequality symbol with an equal sign. So we have x plus y equals 8. Now I like to graph using the x and y intercepts. You can rewrite this in slope-intercept form and graph it that way as well. Okay, so the x-intercept is when y is equal to 0. And if y is 0, you solve for x and you get x equals 8. The y-intercept is when y equals 0, so y-intercept is when x equals 0. So x is gone, and you'll have 2y equals 8, which means y equals 4. Go ahead and graph those points, and we have 8, 0 for the x-intercept, and then we'll look for 0, 4 for the y-intercept. The next thing we need to do is look at the inequality symbol. So it says less than or equal to. Because we have that or equal to, we know we're going to have a solid line. Go ahead and extend out and put arrows. Then the last thing we need to do is a test point. So my test point is going to be 0, 0, because it's available to us. It's right there. Plug it into your inequality, and let's see if you get a true statement or a false statement. So on the left side we get 0, the right side is 8. 0 is less than or equal to 8, so you will shade this half of the plane. And that's the graph to this inequality. Let's look at number 15. Number 15 has x squared plus y squared is greater than or equal to 15. Now, if you do not recognize this as a circle in standard form, centered at the origin with radius square root of 15, you can resort back to how we solved or graphed the first inequality. First thing you need to do, change your inequality symbol to an equal sign. And now I'm going to solve, and I wrote down the wrong number, didn't I? It should be 25. Okay, so now I'm going to find the x-intercept, which means y is 0, so I get x squared equals 25, How you solve for x? Take the square root on both sides, so you get x equals 5 as well as negative 5. And then let's get the y-intercept. That's when x is 0, so you have y squared equals 25. Take the square root on both sides, and you'll have y equals 5 as well as negative 5. So let's graph these points. There's 5, 0, negative 5, 0, 0, 5, and 0, negative 5. Now, this is a circle, and the question is it a circle with a solid line or a dashed line? This is just a greater than sign with no equality underneath it, which means this has to be a dashed line. So it's dashed. Okay, so now the question is, are we going to shade the inside or the outside? So let's use the test point 0, 0. Plug it in for the x and the y, and let's see if we get a true statement or a false statement. Okay, well on the left side we get 0, right side is still 25, but that is not greater than 25. 0 is not greater than 25, therefore we will shade just the outside. Like a sun. Alright, let's move forward. So now, let's talk about graphing systems of inequalities. This time, instead of graphing one inequality, you get to graph two inequalities. I'm going to let you read through this paragraph right here, and I wrote some notes below. So to graph a system of inequalities, the first thing you want to do is graph the first inequality. Then you want to graph the second, and then the last thing you need to do is shade where the two graphs actually intersect. So let's look at number 27. It says, graph the solution of each system of inequalities or indicate that the system has no solution. And we're given the inequality or the system 3x plus 6y less than or equal to 6. And then we have 2x plus y is less than or equal to 8. So let's start by graphing the first inequality. So 3x plus 6y less than or equal to 6. First thing you need to do, change your inequality sign to an equal sign. So 3x plus 6y equals 6. Let's find our x-intercepts, and let's find our y-intercepts. So x-intercept is when y is 0, so this piece disappears, and you should end up with x equals 2. You'll have 3x equals 6, means x equals 2. Y-intercept is when x is 0, so that piece is gone, and you should end up with y equals 1. So let me draw a big graph over here. X, y. So we have the point 2, 0, and then we have the point 0, 1. Now, is it a solid line or a dashed line? Because we have equality here, it's going to be a solid line. So go ahead and draw your line and extend it out. Now we need to pick a test point. How about we pick the test point 0, 0, because it's available to us. Now let's plug it in for this inequality, and let's see if it comes out with a true statement or a false statement. So we get 0 times 3 plus 6 times 0. Is that less than or equal to 6? We get a 0 on the left side, a 6 on the right side, and that is less than or equal to 6. Therefore, we would shade this half of the plane. I'm not going to shade it. I'm going to call it big A, just so I can remember what side I'm actually shading. Big A. Now let's graph the second inequality. 2x plus y less than or equal to 8. change your inequality sign to an equal sign. So 2x plus y equals 8. Let's find the x-intercept and the y-intercepts to graph. And of course, you can use slope-intercept form, you can use your calculator, whatever method you like. So the x-intercept is when y is 0, so this piece is gone. And you'll get 2x equals 8, which means x has to be equal to 4. Y-intercept is when x is gone, so you're left with just y equals 8. Let's go ahead and plot those points. So 4 for x, so 4 comma 0, and 8 for y, so 0 comma 8. Now, is it a solid line or is it a dashed line? Well, there's our equality. That says less than or equal to, so we know we're going to have a solid line through these 2 points. Go ahead and draw your line and extend it out. Now, let's pick our test point. There it says 0, 0. It's still available to us, right? So I'm going to use it. So it's probably one of the most beautiful numbers out there to use. So 2 times 0 plus 0, is that less than or equal to 8? Well, again, you get 0 on the left side, got 8 on the right side, and yes, 0 is less than or equal to 8, which means we would have shaded this half of the region, right? Everything below this green line, or where big B is. Okay, big B is all of this. Now, the last thing we need to do is figure out where do these 2 regions overlap. Well, A is everything below this red line, and B is everything below the green line. Where do they intersect at? This region. Why can't you shade this part right here? Because A isn't up there. And why can't you shade this part here? Because B isn't there. Therefore, they only overlap in this region, and this right here is the graph or the solution to this system of inequalities. Every point that falls in the shaded region, as well as on the red line and the green line, will satisfy both inequalities. All right, last one, number 49. And it says x squared plus y squared is greater than 1. And then it says x squared plus y squared is less than 16. Again, we want a graph, so let's go ahead and start with the first inequality that says x squared plus y squared greater than 1. Recognize it as a circle centered at the origin with radius 1. If not, use the x and y intercepts. So x-intercept is when y is equal to 0. So he's gone. Oh, first thing we should do is change the inequality sign to an equal sign, right? There we go. So the y's part is gone, and we get x squared equals 1. Take the square root on both sides, and you get x is equal to negative 1 as well as positive 1. Do the same for the y-intercept. So y-intercept is when x is gone, so you should end up with y equals positive 1 and negative 1. Go ahead and graph these. Now the question is it a solid line or is it a dashed line? Because we have a greater than inequality with no equality underneath it, we're going to use a dashed line. And then we need to pick a test point. So let your test point be 0, 0. Plug it in. So you have 0 squared plus 0 squared. Is that greater than or equal to 1? Get a 0 on the left side, a 1 on the right side. 0 is not greater or equal to 1, which means we would shade region A, which is on the outside of the circle. Now, let's graph the second inequality. First thing first, change that inequality sign to an equal sign. And then let's find some x-intercepts and some y-intercepts. This is a circle centered again at the origin with radius 4. Well, if you don't know that, we can resort back to our x and y intercept. So x-intercept is when y is 0, so that piece is gone. And you'll get x squared equals 16. Take the square root on both sides, and you get x is 4 as well as negative 4. Y-intercept is when x is 0, which means he's gone. And you should end up with y equals 4 as well as negative 4 too. Let's go ahead and plot those points. And then the question is it a solid line or is it a dashed line? Well, this says less than. There's no equality, so I know I'm going to be dealing with a dashed line. Sort of a dashed line. Now, where will we shade? Well, we need to pick a test point, so 0, 0 is still available to us, so let's use it. So 0 squared plus 0 squared, is that less than 16? So 0 is less than 16, which means we would shade where? On the inside of the big circle, so I'm going to call it big B. Okay, so now we need to figure out, well, which piece are we shading, which region are we shading for our system of inequalities? Well, A is in between the two circles, and B is also in between the two circles, so I know they overlap here, so let's go ahead and shade that piece in. Now, big B is on the inside of the little circle, right? He comes all the way in. But big A, it's not on the inside of the little circle. Therefore, they do not overlap inside the little circle. Nor do they overlap on the outside of the big circle. So the only place they overlap is in between. Let me shade it in. And this will be the solution to this inequality. So all the points that fall inside the shaded piece and the points, all the points that lie inside the shaded piece are the only ones that would satisfy this equation. Because this was a dashed line for both circles, we do not include the points that are actually on the circle. So like this point 1, 0, if we plug it in, it will not work because it's a dashed line. Alright, so this concludes the video for 8.5. Please email me if you have any questions.